Welcome to the Deep Dive, your shortcut to immediate expertise. Today, we're tackling JavaScript fundamentals. We've got this massive academic text,
Huge source. Yeah,
and we're boiling it down.
absolutely. Our mission for you listening is simple. Get the core identity of JS, its foundational rules, and, well, those crucial details that make you an informed insider fast.
Right. Forget just copying code. We're starting with, I think, the biggest shift. JS and the browser. Everyone knows that connection.
Yeah, that's the classic view. HTML, CSS, JavaScript, the front-end trio. But it's identity now. It's dual.
Dual. How so?
Well, it started client-side in the browser, definitely. But the huge evolution is its escape from the browser.
You mean like Node.js?
Exactly.
Oh.
Environments like Node.js let JavaScript run outside the browser, building servers, back-end systems.
Yeah.
It's a full-stack language now.
So the code making a button click is potentially the same language running the entire server behind it.
That's the power. It really did break out of that initial bug.
Okay, but when it is in the browser, security must be paramount.
Oh, absolutely. It's designed to be a safe language in that context. It's sandboxed,
Meaning?
meaning it can't just reach out and mess with low-level hardware. No direct CPU access, no rummaging through memory willy-nilly. That confinement protects the user.
Got it. So what are the hard limits? Like, specifically, what stops a dodgy website from spying or stealing data?
Two main pillars. First, JS running on a web page generally can't just read or write files anywhere on your hard drive.
Generally.
Well, yeah. You can interact with things like your camera or microphone, but only if the browser explicitly prompts you, the user, for permission. It's not hidden.
Okay, so that counters the secret surveillance fear. What's the second pillar?
That's the big one. The same origin policy.
Ah, yes, the cornerstone of web security.
Pretty much. It defines trust. An origin is the protocol, domain, and port together.
Like https.google.com.443.
Exactly. A script from that origin is blocked by the browser from interacting with a script or data from a different origin, say your online bank running another tab.
It keeps things separate. Stops cross-site data theft.
It's the silent guardian, Absolutely crucial.
Okay, that structural security is vital. Now, we know JS is standardized ECMAScript, right? And definitely no relation to Java, despite the name confusion.
Zero relation. A common misconception.
But that standardized code needs something to actually run it. An engine room.
Right, the JavaScript engine. These are incredibly sophisticated pieces of software inside browsers.
Like V8?
V8 is the most famous, yeah. Powers Chrome, Opera, Node.js 2. But there's also Quantum in Firefox, Chakra Core in Edge, Nitro in Safari. They all do the same job. Parse, compile, optimize, and execute the JS code fast.
V8 was kind of the one that proved JS could be really, really fast, though, wasn't it? Making Node.js feasible.
It was a game changer for performance, definitely.
Okay, so we know where it runs. Let's talk about writing it. Syntax, we don't need a full grammar lesson, but maybe focus on the pitfalls.
Good idea. Statements are the basic instructions. And that brings us to the semicolon.
The tiny character that causes so much debate.
Optional, right? Sometimes. Technically, yes, because of something called automatic semicolon insertion, or ASI. But relying on it, risky.
Why? Where does it bite you?
The classic case is when one line ends, say, with a variable, and the very next line starts with something like a square bracket for an array, or a parenthesis for a function call.
Ah, so the parser might mush them together incorrectly.
Exactly. It might think the tepatoup is trying to access a property of the variable on the previous line. You get these silent, really confusing errors. Just use the semicolons consistently. It's safer.
Consistency. That sounds like a good segue to strict mode. What's ustrict all about?
It's basically opting into a cleaner, more modern, and less error-prone version of JavaScript. You put that string at the top of your script or function.
And it changes how the language behaves.
It does. It eliminates some old problematic behaviors kept for backward compatibility. Like in old JS, if you forgot to declare a variable with var and just assign to it, it would create a global variable.
Which is generally bad practice.
Terrible practice. Strict mode turns that into an error. It makes you write better, more explicit code. It's standard practice now for any series development.
Makes sense. Okay, moving to storing data. Variables. We use let now, mostly.
Right. Let is the modern standard for variables that might change, and const for things that shouldn't.
And the naming convention is pretty universal. Camel case. Like my variable name.
Standard practice, absolutely.
Yeah.
But the sources pointed out a really valuable exception to that rule.
Oh. When should we not use camel case?
When you're defining a const that acts as a hard-coded alias for a known fixed value.
An alias, you mean like giving a name to a magic number or string?
Exactly. Think configuration values, or maybe a specific color hex code that's hard to remember, like hashtag FS7F100,
Yeah.
instead of using that raw value everywhere.
You define const colorEng, hashtag FF7S100?
Precisely. Use upper snake case, like colorEng or maxillodusers.
And the uppercase signals something specific.
It signals to anyone reading the code. This isn't just any constant. This is a fixed, predefined alias. Its value is known up front and won't change, and it's here to make the code more readable. It's an organizational convention. So holding these values, JavaScript has 8 data types. Primitives like string, boolean, null, undefined, number, and also object and symbol. What follows on number?
Right, because it's not just for, well, normal numbers.
Exactly. The number type in JS includes your regular integers and floating point numbers, but also special numeric values. Infinity, and the famous nan.
Not a number, the result of weird math, like 0 divided by 0.
We're trying to parse a non-numeric string as a number. Yeah, it indicates a computational error.
And the really weird part.
The weird part is that nan is the only value in JavaScript that does not equal itself. If you check nan, it equals false.
Which seems counterintuitive.
It does, but it's mathematically necessary for how error states propagate.
Yeah.
It means you can't just check result. Man, you have to use the built-in function is nan result.
Okay, that's a crucial detail for error checking. Now, another classic point of confusion, null versus undefined. Can we clarify that quickly?
Definitely. Think of undefined as the default state. A variable has been declared, but it hasn't been assigned a value yet. The system says, I know this exists, but it's empty.
Okay, so it's the absence of an assignment. What about null?
Null is different. Null is an intentional assignment of no value. The programmer is explicitly saying this variable should exist, but its value is deliberately empty, nothing, or unknown right now.
So undefined is passive absence, null is active intentional absence.
That's a great way to put it.
And since we often test things out in the browser, maybe a quick mention of those simple interactive pop-ups.
Oh yeah, the host objects provided by the browser environment. Useful for quick checks.
You mean alert, prompt, confirm?
Exactly.
Yeah.
Alert message just shows a message box. Prompt, question, default. Shows a box asking for text input, returning the text, or null if canceled.
And confirm.
Confirm, question. Shows a message with OK and cancel buttons. It returns true if you click OK, false for cancel, simple tools, but handy for basic interaction or debugging on the fly.
All right, this next one feels like a really important modern refinement, handling default values for variables.
Yes. This trips up so many people, even experienced developers sometimes.
So the scenario is you have a variable, maybe from user input or configuration, and if it wasn't provided, you want to use a default value.
Right. And for years, the standard way, the only way really, was the logical OR operator.
You'd write something like value, receive value, default value.
Makes intuitive sense,
Yeah.
right? Use receive value if it exists, otherwise use default value. Simple, short.
But it had a flaw, a pretty significant one.
A major flaw. The operator doesn't check for existence. It checks for truthiness.
Ah, okay. Explain truthiness versus existence here.
Returns the first operand if it's truthy, otherwise it returns the second operand. The problem is several legitimate values are considered falsy in JavaScript.
Like the number 0?
Exactly. The number 0 and also an empty string are both falsy.
So if a user legitimately entered 0 as a quantity or left an optional text field blank, the operator would incorrectly discard that valid input.
And substitute the default value instead. Imagine setting a product count to product count 1. If the actual count was 0, this code would wrongly change it to 1. Big potential for bugs.
Okay, so that's the problem created. What's the modern, precise solution for use this default only if the variable is truly missing?
That's where the Nullish coalescing operator comes in. It's written as a double question mark.
Double question mark.
Oh.
And how does it work differently?
It's much stricter. AB looks at A and asks, is it strictly null or strictly undefined? Only if the answer is yes does it return B.
So it doesn't care about truthiness at all.
Not at all. It only cares if the value is actually nullish, meaning null or undefined.
Which means legitimate falsy values like 0 or AR are seen as perfectly valid, defined values.
Exactly. They are not nullish. So if you write height down to 100, the default 100 is only used if height was literally null or undefined. If height was 0, it stays 0.
That offers much more predictable behavior, much safer for defaults.
Immensely safer. It's the correct tool for the job of providing defaults when a value might be missing.
Is there anything else to know about out?
Just one safety rail. JavaScript actually forbids you from using dot directly with the logical OR, or A&D operators, within the same expression, unless you use parentheses to make the order explicit,
Why is that?
to prevent confusion. Their precedence isn't immediately obvious. Mixing them could lead to unexpected results. So the language forces you to be explicit with parentheses, like x1 under y. Makes you think about the logic. So wrapping up, we've touched on JS living both in and out of the browser, key security aspects like the same origin policy, why modern syntax like strict mode matters, and crucially, this difference between wording for defaults.
That operator really feels like one of those high-value nuggets we talked about. Understanding that distinction elevates your code.
It really does. It's about precision and respecting the data you're given, even if it's 0 or an empty string.
And speaking of precision and clarity, the source material had this interesting aside about code organization, even for simple things.
Oh yeah, the point about functions.
Right. It said even if you only use a piece of logic once, wrapping it in a well-named function makes the main code flow self-descriptive. Like, having a function is prime and then, even if you only check one number's primality.
Exactly. Naming the subtask clarifies the main task. If prime is instantly understandable.
So here's a final thought for you, our listener, building on that. How could you apply that principle naming and organizing small pieces of work to complex tasks in your own world outside of coding?
Interesting extension.
If you have a complex, maybe even one-off project at work or home, could breaking down the steps into clearly named phases or functions, like step 1 gather requirements or phase 2 draft proposal, make the whole process easier to manage and understand, even if you only execute that project function once?
Thinking about how organizing the process clarifies the result.
Exactly. Something to consider.
Until next time.